welcome back, everyone. Hopefully you're able to enjoy that last session. I know I did. We are really excited for our next session for a variety of reasons. I will let Graham and Slater kind of introduce themselves more fully, but just a quick note from us here in the Center for Digital Strategies. Graham was one of our very first fellows in the center. I won't say how many years ago, but you can read that he's an O2 and kind of extrapolate. But it's really wonderful part about talking about the center and about Dartmouth's kind of culture is this ability to kind of stay connected and that network to matter a lot. And so we're really excited to have Graham back and to welcome Slater into Dartmouth as well. And hope you enjoy the next session. I'll let you gentlemen take it away.
Awesome. Well, thanks so much for having me back, and super excited to be chatting about AI. First of all, just a little bit of ground setting of what we're trying to do here. We're going to try and make it a little bit of a bi-directional fireside chat here. When I was talking to Patrick and Alva about what we're bringing an investor point of view, I wanted to bring someone that was far smarter and sort of the true entrepreneur, really deeply understands the technology. So really quickly, my background, I'm a partner at 406 Ventures, been there for 16 years. I lead our data and AI investing. It's all I've done, it's all I do. And it's really nice to be able to go very, very deep in this technology. Prior to that, I was an engineer and an entrepreneur, always again in the data and AI space. And I met Slater, we were just calculating it, almost 10 years ago when he was a junior in college. And funded his first company, and we just recently funded his second. But I actually was hoping you could talk a little bit about your background, and in particular, sort of, you were right at the front edge of generative AI way back then. Tell us a little bit about the history and sort of, how you interfaced in with it.
Yeah, no, absolutely. As Graham said, we're getting into this about a decade ago. And so I know from a lot of people's perspective, generative AI has been around for, a year or 2 years or things like that. So, Graham was the guy, back 10 years ago when we were going and pitching LLMs and saying like, trust me, it doesn't make a lot of sense right now, but in a couple of years, everyone's going to be talking about it. Graham was one of the folks that actually kind of like stuck through the pitch and it's like, oh, interesting. There really is something here. So I think at a really high level, just to kind of cut to the end, sort of as Graham said, I've been in the space for a while. I think Indico, which is the name of the my first company that 406 funded, has. Is it fair to say that we started generative AI? Is that like it might be a step too far?
I would say that, no.
Yeah, I mean, I'll present the credentials and you can make your own decision, right? So, original co-founder was the lead author of GPT. GPT, and this is like original GPT before Chat or GPT-3 or any of that stuff. It was a direct extension of the work that actually came out of Indico, just like a handful of months afterwards. And similarly, actually on the generative art stuff, I know a lot of people think that the large language models and the foundation models and the generative art stuff is kind of disconnected, but that actually also started back at Indico. So some people here, and actually I think I've seen some slides generated with it, might know the paper DCGAN, stands for Deep Convolutional Generative Adversarial Networks, if you want the really, really long version. But it was the first paper really that showed high quality results coming from generative AI. We published that in 2015, I want to say, somewhere about there. And it's still one of the top 10 most cited AI papers of all time. And so have got, I think, a really interesting perspective kind of going through it from both sides and also being a bit of an EIR at 406. So I've had kind of the privilege to look at a lot of companies now kind of entering the space in the last couple of years, right, on the infrastructure side, on the pure generative AI side, just from all different approaches. So I have a little bit of that perspective, and then also now just that generative AI has kind of reached some critical threshold, right? I think we'll talk about exactly what that critical threshold is. I think a lot of folks are still wondering exactly what happened, certainly on the inside, right? We didn't change anything about the technology, right? But something clearly happened, right? This conversation is evidence of that. And so seeing both sides of the equation sort of through the years, right? And kind of seeing that there's now this opportunity for kind of a second wave of generative AI applications and just how different the technology looks and feels and smells than it did 10 years ago. That's what we're here to talk about.
Awesome. So one of my favorite quotes I heard here today was, if it can be solved with math, solve it with math, right? And so I actually think that as an investor, one of the things that we really look at for each application is the technology use case match, right? So what's a good use case for generative AI, and how do you measure success?
God, I mean, we could have probably a whole symposium just on that question. But I mean, it's a really, really good place to start, right? And I think the last conversation, or even a couple of the other ones that we've had, throughout the day, have given us some really good foundations to build upon, right? So I think number one, when you're talking about something like disparate incomes or risk profiles, right? When you're saying, hey, I've got a particular population that is, suffering in one way or another, right? I don't really think it makes sense to apply AI to that problem, right? I'm not saying that AI is not going to be any like part of the chain, right? But I think that there is a bias in a lot of ways to say, like, we've got problems, we've got AI, it's a new tool, right? So let's mash them together and we're going to solve our problems, right? I think in a lot of cases, like risk, right, is a really good example of, there's not really a place where AI fits into that problem to at least solve the issues that we've got, right? And I think you've heard it, 3, 4, maybe in every single talk that's happened, today, the data is really what matters at the crux of it, right? So when you're talking about something like disparate incomes, disparate outcomes and disparate incomes, before you even bring AI into that problem, you have to ask the question, what does a solution look like here? Right? What does correct look like? What is a representative set of data, right? What is I'll say it just to say it, but like, what does a zero bias situation look like? I think most people realize that there's really no such thing as zero bias, right? We've got some really obvious cases now where we're like, all right, this is a really huge, really, really acute problem, right? But I think if we had to actually get down to a mathematical definition, right, of like, what does zero bias look like, we would actually run into some pretty difficult and intractable issues very quickly, before AI touches the problem at all, right? Just like humans working with other humans, trying to agree, like, how should this thing work? So anytime I look at an AI application, that's what comes first, right? Is this possible? Can humans do it? Right? And if the answer to those questions is no, sorry, like, it's not an application for AI, right? I think saying earlier, right, in that previous conversation, AI is not God, that's really, really important, right? But even more than that, I think the most accurate depiction of AI that I've ever heard that is pretty common is AI is a stochastic parrot, right? AI is really, really good at figuring out something that humans do, that they already do, and figuring out how to replicate that to also almost an arbitrarily, precise replication. In some cases, that's really, really useful, right? In some cases where, the work is just busy work, right? Or where it's really, really consistent and you know exactly what's correct in every outcome, awesome. AI will totally be applied there very, very well. There's a lot of cases, and we used to joke in the early days of Indico, what we call scrape the internet and do magic use cases. And I think you see a lot of this, is people have this belief that you can just like cram data into an AI and it's gonna like look across that and understand it and again, do some magic. So the one that we used to get all the time was like, figure out what companies are going to buy what other companies, right? By again, scraping the internet. Which I think people understand here, that's not a thing, right? You can't scrape the internet. So initially you're right out. But then we would talk to these people and be like, why do you believe this is a possible thing? Why do you think that this can be done? And the answer was kind of like, well, doesn't it seem like it should be possible? And I was like, yeah, I agree with that. But then you kind of scratch a little bit lower and like, well, we've actually got a team of like 200 people that's doing this. And we're like, whoa, like, slow down a minute. Okay, you've got a team of 200 people doing it. What are they doing? Let's start there. And the immediate answer is like, well, they're doing stuff, right? But actually, even though we've got 200 people doing this, we have no idea like what success looks like. They're just kind of doing random stuff. I'm like, okay, cool. AI is a really, really bad application there, right? Flip side, to again just use something from the last talk because I think it's a really good one. Something like intelligent intake, right? Where you say, hey, I've got health forms coming in, right? I need to understand the ICD-10 codes. I need to understand like there's a broken foot here. I need to understand, which hospital are we actually billing for this? Humans do that. There's a correct answer to that. Whether it claims to be approved or not, totally agree. Like, don't let AI touch decisioning. Like, I'm not going to touch that with a 10-foot pole. But where you've got a process that humans already perform, whether they perform it well or poorly, the key is that you know what success looks like. You've got a process that works, even if you don't have superhumans that are going to be 100% perfect in every single case. But once you've got that foundation, I think that's really where you have to look at AI as being applicable. If you don't have that foundation, you're not going to be able to both create a process that works and automate that process at the same time. You've got to like do one and then the other. And Graham, you know, I'd be kind of interested in the flip side of this problem, right? So like me as a technologist looking at it, those are the problems that I really like. From an investment perspective, right? You know, when you see folks, and you know, a lot of these tourists, I think we've started calling them, right, that have come into Gen AI in the last like year or two. You know, obviously there's a lot of application. What does a good positioning look like to you? You know, what does a good application area really look like from a business perspective?
Yeah, so I think that there's a couple things that are playing in here. I mean, this technology, as we all know, is changing so fast right now. So we've got in the investing side, we look at sort of 7 to 10 year plus horizons. And so how do we predict where the technology is going to be in 7 to 10 years to make sure that we are going to have a massive outcome? I'd almost break it out on the stack. So you've got foundation models, right? You've got infrastructure, and then you've got the application layer. I think it's different on all sides, right? Starting with the application layer, that is really, I mean, that's sort of, it's really about sort of deep functional expertise that's being fed into the application, because you're going to be differentiating on your ability to honestly hide the AI as much as possible, fit it into the existing workflows, and win on brand, right? And so there, it's really about who is the founder, what's their experience, what's their credibility, what's their network that they're bringing, et cetera. The infrastructure layer is probably the place that we're spending the most time. And I think that this one you actually can sort of look at the technology, take the covers back a little bit, and really sort of predict out where things are going to go. Because we assume that the foundation models are going to continue to get better and better, and I think there's going to be rapid change there. I'm not going to bet on which the leading foundation model is going to be in 3, 4, 5 years by adoption. But to make those foundation models really usable, I mean, as you saw at United Health Group, they're going to be doing everything, right? They're going to be building their own foundation models. They're going to be fine-tuning models. They're going to have, it sounds like, thousands of models. So there's a lot of infrastructure that needs to go into that. And it's a known sort of process to how to fine-tune it, how to leverage reinforcement learning, et cetera, to really make sure that you can take as small a model, as narrow a model as possible, and get the best results out of it that you can. So from there, it's really trying to look at sort of where the puck is going and invest in that side of things.
Yeah, there was one thing that you said that I just want to like re-emphasize, because I think it's so core, right? But thinking about that application layer, right? Like what are a lot of the most successful applications of AI? And I think a lot of people get really caught up in this mentality of like, I mean, generative AI is new. Generative AI, well, I mean, it's not really new, but like it works really well now. It's really cool, right? And so I don't want to like take away from that. But I also think that 9 times out of 10, right, the application that you're actually going to see at the end goal, right, is not something that is actually directly relevant to generative AI at all, right? The only applications that are really going to be successful in my mind are places where you target an experience that people already wanted, right? And if you try to design it in a tech-forward way, and a lot of people do this, right? Even like, I'll invite designers in, and the first question they ask is like, cool, what can the AI technology do? I say, nope, stop, like right out, like you're on the wrong path, right? The core is come up with an experience that is actually better for consumers. Not to go into it in a super deep amount of detail, but with all of the different pieces of technology, just talking about everything that we've been over in this session, or even just talking what you talked about, there's so many ways that you can apply this. There's so many different tools that you can build, right? If you've got a couple of people that know ML, not even at like the super high level of building their own models at a place like OpenAI, but even just people that can fine tune a model and pull down an open source repo and run it, right? The amount of things that you can create, if you really understand the connection with that in product, is so far beyond what you see in the market today. I think that is, and it's funny, like the most relevant skills to be successful in AI have nothing to do with AI at all. If you really just have that ability to focus in on what a user wants, and then think about the AI as more of an afterthought and really get into that dedicated mentality, I think that's the biggest predictor for success for folks.
I totally agree, and I think that one of the things that we really love seeing is a deep subject matter expert partnered with a deep technologist, right, in companies. So I think that those, we actually honestly rarely see that. It's usually a bunch of deep technologists trying to create an app for a specific industry, or people with deep industry experience without that technology backbone. So just to build on what you're saying, if you look at sort of the rapid change in this technology, right? I mean, if you think about just parameters for early GPT models up to sort of where we are now, it grew 100,000-fold in like 4 or 5 years. So what's interesting now? Where do you think the technology is going to be? Like, what is sort of cutting edge research that you're most excited about?
Yeah, so I think the thing that's really interesting is like how different this technology looks from the inside and from the outside, right? So, and I was talking with one of the core people behind ChatGPT actually right before it launched. And I think it's very, very informative because nobody at OpenAI, not a single person inside that organization, thought ChatGPT was going to be a big deal. They were actually embarrassed by it in a lot of ways, right? So some people might know this, some people might not. The actual version number that ChatGPT was originally pegged to is GPT 3.5. And you're like, that's kind of weird, right? Like there's GPT-3, there's GPT-4, like why did they have this weird half version? So ChatGPT was actually them being like, oh, you know, we didn't actually make enough progress as we wanted. We really wanted to come out with GPT-4, you know, that's what we were gonna launch. But like whatever, we've got this reinforcement dialogue thing off to the side, someone's just been coding, like whatever, you know, we'll launch it, you know, people like leave us alone for another 6 months till we can launch our big thing. And I mean, you know, lo and behold, right, it was very, very different. But I think the thing that's really core to understand is from the technology side, right? And they'll even say this in all the ChatGPT papers and all the GPT papers. The architecture has not changed in 8 years, right? It is literally the same code that they're running, just with more data, with more scale, right? And so I think all of that's to say that a lot of the technology that I think people are really focused on in this space, right? You know, what's a better activation function? What's a better neural architecture? Things like that really doesn't matter. And you know, I know coming from kind of the more research, the more tech side, that's like sacrilege to say like that's really not where you should be focusing, right? I think a lot of the core things that I think are really going to drive this next generation of innovation, you know, a big part of it is just engineering. People might realize, but at OpenAI actually, they've been going really intentionally away from their strategy in kind of the last, you know, maybe year, 18 months of, you know, only hiring PhDs. You know, it used to be just like, PhDs, that's it, like we don't care, we're just doing super, super deep research. Now they're like, we kind of got enough PhDs, we really want platform people, we want engineering managers, we want people that can actually get data plugged into this because they've realized that, you know, even if you keep all of the models exactly the same, scaling up that user input, scaling kind of the kinds of data that you can ingest into your system, the numbers of different ways that a person can kind of direct them, that actually is where I see a huge amount more potential. And you know, even for me, even that's not like, you know, even if it's not super, super mathy in a lot of ways, there is a really big arc that I think is really going to drive a lot of this next generation. It's something, a term that Microsoft came up with called machine teaching, as opposed to machine learning. The idea there really, really briefly is that new interaction paradigms between humans and AI is really the potential. You know, that's where kind of the center of the target is. And so the idea of, I'm trying to figure out how to say this in like 90 seconds without going like too deep into the weeds. But the idea at its core is traditional machine learning, something like sentiment analysis, or even let's use like health outcomes, even though I think we all agree like that's a super bad use case, but it's at least simple to describe. I've got some input that comes in, some customer data, and I'm trying to predict like yes or no, this person gets diabetes, let's say. Turns out that's really, really far from how humans actually approach that problem, right? You know, you're never as a physician just being like, yes, diabetes, no diabetes, you know, like it's just a very inhuman process. And so what that means is that when you actually present the problem in that way to an AI, there's a fundamental like cap at how good you can accomplish that task. Sentiment analysis is another good example of, you know, if I'm taking tweets in and just saying this tweet is positive, this tweet is negative, well, we all know that tweets aren't purely positive, they're not purely negative, and so there's a fundamental cap to how well you'll be able to do with the problem using that problem constraint. And so and that's all like machine learning world is like, computers are really good at categorizing things, so let's turn this into a categorization problem. Machine teaching says, no, like throw that away, you know, we're gonna invert this. We're gonna say, how do humans teach one another to do this task, right? Coming back again to this human element, saying, if I'm a social media manager and I'm reading a tweet and I'm trying to teach, you know, an intern, here's how to interpret this, here's what this means for our brand, right? That's a totally different process than just saying this is positive, this is negative. You're gonna be like, that keyword matters, you're gonna be like, this phrase is really important to us, you know, that's a good one, that's a bad one. And so, so what machine teaching roughly says is that if you can take those processes and kind of encode them in your AI objectives and say, let's build AI the way that humans, kind of teach other humans, you get radically higher success rates. There's a lot of difficulties in actually doing that in reality, but I think the people that are able to actually execute on that vision and actually build those applications that have new user interfaces, but also importantly, new user interfaces that are connected deeply into this fundamental technology and like new learning paradigms and new ways of teaching AI. I think that's really kind of the next, at least several years, what the biggest success stories are going to look like.
And when you talk about that, is that actually interacting with the model during the training phase, or during the fine-tuning phase, or during the usage phase?
I think today they feel really, really distinct, and tomorrow they will not. To use like a cop-out answer, I'll say yes, right? But I think ChatGPT is a really good example, right? ChatGPT is something that has had such a huge amount of active human involvement in its development. A lot of people don't realize this. Like, ChatGPT is a really powerful foundation model, but they also have people that are, hard coding things in, like, if someone asks about politics, route to this other language model, right? If someone asks about, X particular news event, or asks us to put out, like a physics equation or something like that, people that are actively going through these moderator reports and making kind of these hard-coded pressure release valves almost for ChatGPT. So I guess, all that is to say that I think that the process in the future is not going to be so linear, right? I think that companies that say we're only going to provide a foundation model and fine tunings on your own and uses on your own, those products are not going to be really sticky. I think that having gone through this a few times, once you've got something in production, you've got all these different data streams coming in a really organic and kind of heterogeneous way. If you have to try to solve that yourself as a company, it's almost like starting from scratch, right? And so I think companies that really have a determined way of saying, like, here's how we're going to bring in your live data, here's how we're going to integrate the fine-tuning, and really having kind of an end-to-end solution. And foundation models are going to be a part of that. But maybe 15 to 20% of the actual implementation effort is going to be the foundation model in the future.
Interesting. And I want to key off on one other thing you said, which is, sort of it's less about the model and more about the data. So more data means more compute, right? And it feels like, A100s, access to the actual GPUs is the constraining factor right now. Do we see that sort of continuing to scale linearly in terms of more compute equals better models, or is there going to be a break point where Microsoft and Google are no longer sucking up all the compute because it's not a one-to-one relationship?
I don't think there's going to be a future where they stop sucking up the compute. I wish I could say not. But I think for the past decade, it's kind of been the same, right? I think buy NVIDIA stock.
Yeah,
that's the first thing. Always buy NVIDIA stock. But no, I think at every point in the past decade, right, we've had exactly the same issue. First it was you can't get GPUs on cloud compute, right? And still to this day, a lot of people don't realize, like, you can't get a GPU spot instance. Like, it doesn't matter what version you're going for. Like, I can't get a 980 spot instance, which is now like an 8-year-old GPU model, right? And even still, even though like it's an 8-year-old GPU model, it's still going to be $400, right? Which is crazy. Like, you do not see that with any other consumer good. You don't see that with any other piece of technology, right? So I don't think that part is going away. I do think that there is a mode right now that people are in where they almost don't care. They're like, whatever, it takes a lot of compute. I'm OpenAI. I've got a $100 billion data center that Microsoft is putting together for me to play with. Or, sorry, 100 million so far. But I think what people aren't really realizing is that it was actually the reason that a lot of the first AI winter got kicked off. A lot of these models are actually more expensive to run than humans. And that's crazy to think about. Thinking back to the 70s and 80s, maybe it wasn't so crazy because it like filled up a room and having a machine do translation being more expensive than a human doing translation. It's like, okay, we can kind of wrap our heads around it. But I think people don't realize that we've actually gotten to that same point again, right? Where if you just look at the raw cost of having like ChatGPT run an answer in a chat room for normal customer support, it's actually a lot more expensive than having a human do that same thing, which kind of changes the dynamics a bit, right? So it's not an answer so much as it is I think there's going to be a lot more focus on the unit economics and how to make these things actually viable to run at scale. I don't think it's going to reduce demand on GPUs. I think it's going to radically increase the demand on GPUs because once we actually make these things efficient, there's going to be way more demand for them. But I think there's not a lot of focus on it today, right? I think that that's still to come, and so I think that technologies that really can understand, how do we get, an order of magnitude savings on compute. Tremendously valuable. I think right now all of it happens inside of companies, but companies that can figure out how to do that in a generic, horizontal way, I think there's a huge potential there.
Yeah, I'll tell a quick story. We were talking to a startup that went from 0 to 10 million in revenue in 3 months. And we went and dug underneath the covers, and it turned out that their ARR was only 600K, and the other $9.4 million was just reselling GPUs. And so basically, they got a bunch of spot instances, and customers were signing up for their service just to have access to these GPUs.
Yeah,
it feels unsustainable to me, but
it feels unsustainable, and it's crazy, right?
Yeah.
You want to know something that's crazy, right? Is what do you think the I'll just say, the answer, but I kind of want to invite the audience to meditate on this for a second, right? If I buy a GPU on the cloud and I'm I want an A100, right, and I want that for 2 months, let's say, what do you think the payback time is relative to just if I bought that GPU myself and had it sitting at home, right? Because normally, right, a whole CPU rack, maybe I'll spend $5,000 on it, right, but it's only going to be couple $100 a month maybe to run that on the cloud, so you got 2-3 years of payback time. So again, just think, what do you imagine that is for GPUs? It's between 1 and 2 months. And again, it has been for a really, really long time. Part of that is because NVIDIA has different pricing, and it's 50 grand to get a server unit of a particular GPU, and getting a consumer grade might be 1 grand, right? But I think the fact that cloud compute is still at such an insane premium. Here's actually a fun fact that, again, but my new company, Mythica, we have not used any cloud compute yet to date. 100% of our hardware today, and I'm sure this is going to change, but 100% of it is on-premises physical hardware. It was the same way at Indico. I built a lot of hardware. We had basically a small data center on-prem, but we'd build these $5,000 workstations that would have 3 GPUs on them, and again, you can't outcompete that with cloud. And so I actually think that's going to be a really big shift. I think that you've already started seeing people go in that direction, but people sort of thought that the cloud economics would correct, and they haven't. So I don't know. I think getting used to dealing with physical hardware is very much in our future.
Awesome. So I'm going to shift gears a little bit. Another sort of big constraint that we have here, and we've talked about a bunch here, is responsible AI. Right? How do we grow responsibly? What role is regulation playing? How do we make sure that the U.S. continues to stay competitive when other countries may or may not have regulations?
Yeah,
softball.
Yeah, that's a really easy one. Yeah, let me just solve that problem right quick. No, so and I do want to flip this back around to you in some ways, but maybe let's start on the regulatory side, right? I think the U.S. has fallen behind the curve here, and we're really starting to hurt for the lack of regulations in this space. I do really applaud OpenAI kind of standing up and saying yes, please regulate our industry. But I don't think a lot of people realize how bad it has already gotten, how late that call to action is, and I think honestly how authentic it is, right? It's a very different situation in Europe, right? I think they were out of the gate early with GDPR, and there are a lot of really good protections in there that I think do meaningfully help to mitigate the harm of AI. But in the US, we've been I don't know, this is complicated, we're not really going to do anything. It's led to a lot of harm, but I think what a lot of people aren't necessarily appreciating is that it has also led to a pretty tremendous slowdown in industry, right? Because the problem now, I'll use Indico, my last company, as a good example, dealing with a lot of financial services companies, some in the healthcare space, right? When there isn't a central regulatory body, everyone just kind of does their own thing. Right, so it means every time Indico walks into a new company, right, we've got to figure out okay, what internal kind of regulatory framework are they using in this case? It's a total grab bag of random stuff. Really, nobody knows what they're doing and what it means for companies that are actually trying to do things in these security-intensive environments. They've just got to do it all, and they do a whole bunch of random stuff and stuff that's not really helpful. So I believe that a reasonable set of regulation in the U.S. that is data-centric, that uses a lot of the lessons from GDPR, would actually have like an acceleration or like an accretive effect on industry. I'm curious on your views there, just purely on regulation, though.
Yeah, I think that it's. I mean, again, I think the only being a regulator right now is insanely tough. I really, really don't envy them. They're trying to come up to speed with the technology is changing that fast. I think that it's a really fine balance between squashing innovation and to your point, actually providing rails so that people can adopt it. Yeah, I think that just knowing how the pace that our government works, there's going to be some regulations. My gut just is that it's going to be relatively light as opposed to Europe, which I think is definitely going down a more aggressive regulatory path. And I think honestly, education is probably almost as effective because I just keep coming back to one thing that we said earlier, which is it's about matching the technology to the use case. There are so many places where humans are better than generative AI, where traditional AI is better than generative AI, where a decision tree is better than generative AI, right? And the thing is, all the other options there are observable. You understand what's happening. You can, if you put the same input in, you're always going to get the same output out, right? You understand why things are happening, and so those are all critical. And so I just want to, I mean, I think people look, again, generative AI is God. I want to move people away from that as fast as possible. And as people internalize that, having regulations around the summarization of documents, like that becomes a lot less important, right? I think it's around the prediction side that gets scary. It's around the content generation side that gets scary. One of the things that was mentioned earlier today is around the sort of weaponizing of fake content. I mean, I don't have any idea how you regulate that, right? I mean, I think that's going to be a real problem moving forward.
We were plenty successful making that a problem before generative AI. But no, I mean, I think that is a really fair point, that even to the extent that we can come up with regulatory frameworks, GDPR is like a good example, but GDPR really is for consumer applications, right? It's really good, if you get like denied a health claim, right? They've got good protections for stuff like that. But when you're talking about a lot of the big scale kind of B2B stuff that we're talking about internally, really all of that is kind of a black box to GDPR, right? They have taken a different approach, which is like, if you can prove a disparate outcome, like we don't care how you did it, like you can sue the person. I think that makes sense, right? But I think by and large, right, when you're talking about what sensible AI regulation looks like in healthcare and what it looks like in insurance, right, what it looks like in media production, right, very, very different, right? Some of those I think relatively straightforward, in insurance and underwriting, there's a solid regulatory body to start on. There's a couple of tweaks that it needs to happen. But on the copyright side, fair use is dead, right? I think the earlier decision that someone referenced about the Supreme Court saying AI is just not copyrightable, or sorry, I think that was an appeals court, maybe not the Supreme Court yet, but it's clearly a wrong decision, right? Nobody that knows like 30 seconds of copyright law can look at that and be like, yeah, this is going to stand, right? Because that's something someone spent 14 hours, right? I mean, yes, there was a tool involved, right? But it's like 14 hours of human effort to create like one particular image, and to say that there's no copyright around that is just doesn't make sense, right? But more problematically, and I think a lot of people don't realize this, you actually can patent it. Because there's a process that was followed to get you from one step to the other, and you can patent processes. And copyright and IP law is very much not supposed to work like that, right? The idea that you can have no copyright protection over something that you do have a patent protection for is just kind of like a null set of legal outcomes. And so I think we've got kind of these contradictions right now that we don't know how to solve them. I think we see really disparate decisions coming out of different courts in the US. And that's a lot of, I think, what I mean by like, we're sort of behind the ball already in a lot of these pieces. I don't know what, I don't envy the regulators. I think they're in a really, really tough position right now. But I am curious, thinking about, sort of explainability and responsibility, right, and things along those lines, like, what do you see out of portfolio companies, right? I think, explainability means a lot of different things to a lot of different people. And responsibility means a lot of different things to a lot of different people.
Yeah, I think we touched on it. I mean, the different industries have a really deep focus on this, and it was mentioned earlier that there's a very deep process at Bank of America before AI gets put forward. And I've talked to a lot of financial services companies, not Bank of America, but a lot of others. And what we see there is that there's a process, but that process is they need 50 or 60 signatures before they launch a new model, right? So there's no actual science in it because they don't understand how to regulate it. But they just make sure that everyone gets a chance to get their hands in it before it gets put in. And that's hugely reducing the adoption of AI. And so we've actually been looking at responsible AI for a couple of years now as a thesis at 406. And not because as we looked at sort of the ROI to justify that thesis, it wasn't to avoid regulatory fees. It wasn't to avoid frontline headline risk. What it was to accelerate the adoption of AI, right? We have a belief that all these companies are going to get to the point where United Health Group was, with thousands of AI models deployed. And most large enterprises are in the tens right now. And so trying to figure out what are the blockers to that. And again, I think really understand the observability, the fairness bias, et cetera. And that's actually why I asked that question of Sandeep, because about sort of how is he thinking about models, right? Because I think that any model that's trained on the internet as a whole is going to have inherent bias and hallucination risk. And I think that so we're starting to see more and more companies look at not just fine tuning but actually building their own foundation models. But it's still an incredible cost today.
Yeah, and I mean, frankly, building a new foundation model won't solve the problem either, right? Yeah. I mean, I think you can definitely make arguments that maybe missteps have made in the in the creation of a lot of these foundation models. I think definitely a lot of people did not get their data in very equitable ways. So I'm not saying there's no reason to make new foundation models, but I think looking at something like hallucinations, a lot of people I think have this view that once it just gets like a little bit better, it will stop doing that, yeah. Right? It's just not how it works. If anyone's interested, you can send me a LinkedIn message afterwards, but it is a really fundamental technology mismatch. Things like ChatGPT have no concept of a fact. The best example I can give, right, and this is kind of my tongue-in-cheek joke, every time someone talks about ChatGPT and AGI, right? Do you think we will get to AGI before or after ChatGPT learns how to count? Spoiler alert, ChatGPT cannot count. It is really, really easy to see if you ask it to generate any text of any prescribed length, it will fail. You say generate like a blurb that is 100 characters long, not only can it not do it, right, but then when you ask it later, how long is this thing that you just generated, it'll be like, this is definitely 100 characters, I'm 100% confident about that. It'd be like, it's just literally not. And actually to make things even more interesting, because it is dialogue optimized, and I think that's something that people don't often realize, is ChatGPT is very much specialized to deceive you, to look like it is reasonable regardless of truth. And so that means you can actually convince it of things. So I've got this exercise, and people can kind of go through and do it on their own. If you give it a piece of text, and you're like, hey, I want something, just tell me how long it is. They'll be like, this is 150 characters. You can say, nope, you counted wrong, it's 160 characters. And they'll be like, oh, obviously you're the human, you know better, so it must be 160 characters. You can't change it too much at one go, but if you keep doing that cyclically, you can actually get it to expand its estimate of any length of text almost indefinitely, right? So, I've built up examples where you have a single sentence and ChatGPT is like, oh my gosh, I'm so sorry, I'm so bad at counting. That's definitely 1,000 characters long. You're so right, oh wise human. And I think it's cute, right? It's really silly in a lot of ways, right? But at the same time, I think people don't necessarily understand how profound that lack of grounding is in this technology, right? And it is something that, in a lot of applications, it's not going to matter, right? I use ChatGPT all the time. So have a friend to talk to, it's great. Or I mean, Eliza back in the 60s with 10 sentences still did a great job. It did meaningful benefit for people in a psychiatric context, right? So it's not to say you can't have any applications, but this hallucination problem, this bias problem, right? It comes from a really, really fundamental place inside of this technology, and incremental changes aren't really going to fix it or improve it.
Is that why all my Mid-Journey pictures have three fingers on each hand?
Yeah, that's exactly why. Yeah, no, another thing, if you want to see it, ask Mid-Journey to generate an image of anyone with any color eyes. It really doesn't matter. Be like, make a wizard with pink eyes, make a dragon with green eyes or something like that. It just won't be. Maybe once in a blue moon, by random chance, you'll end up getting it. But when it comes to really anything specific, anything that is kind of verifiably true, it's just a huge gap, right? And I think it's something that many people are willing to kind of brush under the rug and be like, I don't want to think about it too much, right? I'm sure it won't be so bad. But I do think there's a lot of space for real technologies to actually step in and solve that problem. Hopefully to accelerate adoption. That'd be really nice.
You want to actually talk a little bit about Mythica and how you're thinking? Or?
Always.
Okay, good.
Please.
Go for it.
You think
because you're solving you're looking to solve this exact problem and trying to avoid what we saw in Hollywood, where you had this confrontation between the artists and the technology.
Totally, yeah, and even back at Indico when we were doing like document intake and things like that, I think when it comes to AI really broadly, and I think this is what a lot of people get wrong, and I'll flip this question around to you afterwards, right? Is people believe that it's a really good automation tool, right? And I just think that's actually kind of fundamentally wrong. AI is really bad at automation because the thing is, automation does not have a human touch, right? When it comes to designing a product that is actually going to be based on top of AI, if you go into it with this automation mentality, the human experience is not relevant, is not really important, right? Like Hollywood is an example. If you go into this with the mentality of like, we're going to automate away writers, not only does the AI like not actually work that way in a really effective way, but you end up like kind of undercutting the core value that you're bringing, right? These things are stochastic parrots, right? So, an AI is only going to be as valuable as the writers that underpin it, right? And I think people get really, really confused about that. One just small anecdote to go way back in time, and a lot of people don't realize this, but DC GAN, the first thing that showed this generative art, the generative part was actually very much not the point. For a long time, for maybe the first 6-7 years of this investigation, the fact that you could generate images as an output of these models was like, oh, that's kind of cute. And it was actually really seen primarily as a way to introspect the model, right? Like nobody really thought that these things could be products in their own right. It was like, hey, if I ask it for a dog and it makes me a dog, then that means it understands what a dog is, right? And again, that was the kind of investigation that we were doing. I think that things have changed really, really dramatically. Obviously, like generative AI is kind of the thing that people are looking at now. But I think what people miss is that it is just a small part of the process. And I think that the only way that you build something really successful, and this is what we're doing at Mythica, so hopefully it works out, is not saying we're going to come in and Mythica, by the way, we're making digital trees, right? So kind of big 3D large-scale environments. If you come in there and say, we're going to automate away all your technical artists, all your environmental artists, all your like foliage people, and we're just going to like, bam, give you a world, it's really not compelling, and you're going to get pretty boring stuff out the other side, honestly. So what I think is a lot more compelling when you look at AI applications broadly, you have to ask that question, how are the users and the AI coming together in a way that is actually accretive to both of them? It is not about automation, it's about augmentation, right? It's about acceleration. It's about what are the things that you can give to a person. And you saw a lot of really great examples with United Healthcare, right? What makes that chat experience so successful is that it's not an automated chatbot. It's something that's going and in an automated, super, super efficient way, getting that rep everything they need to know to make that interaction happen smoothly. And I think that's really what a successful use case looks like, right? It's turning people into superheroes. It's allowing them to really focus on the parts of their work that they find engaging and enjoyable, right? But they're never going to be removed, right? And the applications that I think are successful are the ones that put them at the center of the target.
Awesome. So I was going to open it. We got just a couple minutes left. We want to open it up to some questions from the audience.
About asking a large language model to count, another way to solve that problem or to approach it is to say, write a Python program that counts words and sentences, and I'll bet you it's a correct Python program.
Probably not.
No, it is. Anyway, try it.
I'm confident.
But, well, I've done that with parity. I guess I haven't. But I'll give it a bit string, and I'll say, what's the parity of this bit string? And compute it when it's 20, 30 bits. Write a Python program to compute the parity of a bit string, and it's correct. But But then you ask it, execute this Python program on this bit string, and it can't, right? So, but that seems to be something that's feasibly doable. Not within the large language model, but within some augmentation of it. So I'm just thinking there are certain things it can't do today, but I'm not sure it's not possible a year from now.
No, I think a lot of people have that point of view, and we can talk about it in some more detail, but let me give a really simple example as to why it's not the case, right? Let's use that counting example, right? I am quite confident that if you say, hey, count the number of words in this string, no, take this to bank, I'm 100% confident. If you say, get me a Python program that is going to count the number of words in this string, what you get out the other end, it will run. It will give you a number that is sort of close to the number of words in that sentence, and it will not be correct. I'm 100% confident in all three of those things. And the question then becomes, okay, cool, we want it to get better, right? Okay, cool. Presumably we can do this because we can count the number of words in the string, right? And so we can maybe have ChatGPT automatically go, generate a few of these, and we can check, okay, this one actually seems to work. Hope is because it's generating Python code, it's gonna be more liable to be consistently correct than if we were asking ChatGPT in its own. And I'll cede all those points, right? That is totally a possible flow. That flow is only successful because we already know the solution, right? And so, yeah, in use cases where we automatically know the solution anyway and can get to it in a totally deterministic way and we know the answer, like, yeah, sure, we can generate that consistently. But then, you know, it's this catch-22, where it's like, well, then there was no point in having AI do it in the first place, right? The only way that, you know, we can go and verify that easily, you know, the vast majority of code that gets written by ChatGPT or any of these is just like wrong and it won't run, because it like confuses variable names and stuff like that, right? And so using that for things where you don't already know the answer, right? You know, that's what people are interested in doing with AI, right? And that's also kind of fundamentally the thing that you can't do with it, right? What I say to people all the time is like, AI's got some accuracy. You can think of it as having some accuracy. But even if you have something that is 100% accurate, right? Like I'll even say, like, say it is a magical AI and any question you give to it, it's going to give you the right answer. How do you know, as a human, that the answer is going to be correct? And that actually ends up being a really, really hard problem, right? Because you have to determine what is correct. You've got to find a way to evaluate it. So if you can find a way to evaluate it, if you can get that testing in place, then yeah, you can do some really, really incredible stuff with AI. But you can't do it without that in place. So yeah, hopefully that's helpful.
So I'm curious on the topic of hallucinations. Presumably, if you have some substantial form of AGI, right, you won't have those illogical hallucinations. But you're saying those hallucinations aren't going to just go away as these large language models get more advanced. I'm curious, do you think it's possible we're sort of going to reach an end in the road? We're going down a path where we can't further prevent those hallucinations, and there's another sort of path we should be going down if we want to reach real AGI?
Yeah, I mean, so people that don't know the subtext of what he just asked, so this is like the Gary Marcus, like, or, you know, there's a lot of skeptics that have this kind of view. I think there's maybe like two answers I'll have. I think number one, LLMs are not going away, right? I think there's a highly motivated but incorrect portion of academia that's just like, throw it all out, like throw the baby out with the bathwater, right? And it's just kind of silly, right? Like LLMs, they work, like they clearly do beneficial things. However, at the same time, you are never going to solve the hallucination problem, right? If you even like frame it as like there is a distinct thing of a hallucination problem, right? I kind of take a different view. It's just like, it just works in a totally different way. Like you expect hallucinations the way that we train these things. And so, yeah, the current way that we are approaching things, I would have no expectation that we are going to, you know, solve the hallucination issue. I just think, despite like paying lip service to it, no one is really interested in it. There's not really a strong like commercial concern. Like, yeah, like when you think about like this ultimate end state of like an AGI that is like omniscient or whatever, right? Yeah, you know, sure, there's value in that, right? But I think people have not really found a lot of use cases where like, yes, you know, a chat interface is useful, and I want it doing, you know, specifically like these kinds of facts, you know. So I think the core thing to remember is just like, ChatGPT is optimized for dialogue. It's really good at dialogue. The question of like fact retrieval, right, or doing like advanced analytics or any of these things that are more factually based, nothing wrong with LLMs, right? It's just a different problem, right? It's one that people aren't really solving. And my like very hot take is AGI doesn't exist. I think AGI is like an ill-formed enough concept that I have not found anyone that can find a line for me between AGI and omniscience. And like I think if you can find that, then like great. But I think most people are like, yeah, AGI is gonna stop nuclear war and global warming and stuff like that. I'm just like, like we've got 8 billion people, right? If we're able to create a person in silicon, right, one more person, we've achieved AGI. I don't see how one extra person is going to solve global warming, right? So I think that's kind of a somewhat fundamental view.
I would like to hear your thoughts on embedded applications such as autonomous vehicles, airplanes, things like that, and how the hardware technology may impose a plateau on the artificial intelligence and applications for those things. We know like we'll not be able to squeeze more transistors into a semiconductor a lot, so maybe you require new technologies. So I'd like to know your thoughts on that.
Yeah, so I think there is a question of like pure raw compute power. I think my view is that there's a lot of ways to shrink the footprint of these things and get them running on smaller pieces of hardware. I do think, however, that there are a couple of core things that aren't super solvable. And using self-driving cars is a good example, right? If you look at Tesla's approach versus Waymo's approach, for instance, right? Tesla uses pure computer vision, right? And they've got sizable hardware, whereas Waymo and most other folks have a much more complex like LiDAR setup and a more sophisticated sensor pack. The trouble is really the unit economics. I think that's what it comes down to for me, right? Because like, yeah, I can chuck a workstation in the back of Tesla. It actually wouldn't be a problem, except for that's going to be like $20,000 additional dollars of hardware, right? And if we look at kind of the whole hardware and sensor pack on top of a Waymo car or something, I mean, it's probably like 150 grand. And that's why Uber was so interested, is because if you look like who actually can make 150 grand from a car. Well, yeah, like if you're running a taxi service, then maybe you can make that amount of money, right? But Tesla is, fundamentally constrained not by like what's possible, what can you fit in a car, but what is actually economical for a consumer to purchase in their car, right? And there's not an easy solution to that, right? Like this hardware is insanely expensive. Having it embedded in a way like that is still not really practical broadly. Huge props to Tesla for trying, but I think that. And the other thing is like cloud compute doesn't really solve the problem just because the data transit is so insanely expensive. There's not an answer so much as like I think the focus is really around unit economics, and I think like if there is enough money to solve the problem, then pretty easy to solve the problems, right? You can fit a lot of compute in a relatively small piece, like the Google Corals are actually like really, really powerful machines. But all that in the world, doesn't help you if you can't, fit 20 grand extra in your bill of goods.
I think that's actually going to be mimicked in how we see the evolution of large language models in general, right? As you look at the cost, as we mentioned earlier, ballooning as people add more and more parameters. I think that may well be what triggers sort of the drop in the hype cycle.
Hi guys, so my question is about open source. So Graham, you had some interesting observations last night. I think I heard Sandeep say that they were using open source as a method to kind of keep costs down. I'm just curious, how does it shape the future of AI? What impacts is it going to have?
Yeah, I mean, one thing I love about AI broadly is that it is probably the most open academic discipline on the planet. A lot of people don't realize this, but like the standard for an AI paper is like you release the GitHub, you release your pre-trained models, right? You put the paper out on archive, right? And you just kind of open it all up and you're just like, here's how we did it. You don't see that anywhere else, right? And look, AI can always be better. I think like the number is like, maybe it's only 60% of papers that release with code, right? But like the average is like 5% across the industry, right? Or across academia. And so I think that open source is here to stay. I think that historically, it has always been the case in the AI space that open source offerings are where the bleeding edge is. I think it's a double-edged sword, right? I think that for a lot of companies, you've just got to realize critically, there's generously 1,000 people in the world that can, I'll say, effectively and responsibly use open source offerings to make something that's really, really good. There's probably 100,000 people, right, that can make something open source and like run the GitHub like hello world sort of thing and get you something that sort of works, right? So I think that using a kind of a third party from a pure like indemnification perspective is still super, super valuable. I think there's a lot of user problems, right, and a lot of application layer things and just getting the unit economics in a reasonable state that again open source is not going to solve for you. And so I think there's still very, very compelling reasons to use third parties in a lot of ways. But I do think if you are an AI company getting founded today, with very few doubts, I think you're going to be building on top of something open source. There's not enough tooling or functionality right now around things like ChatGPT for a company that wants to be living in generative AI to build their own stuff. I hope it changes, but I think that outside of like kind of the consumer space and a couple of like high risk businesses, I do think open source is going to be pretty dominant. Yeah, you should probably add something to that.
I think we're out of time.
Never mind then.
Want to thank you both for a wonderful and engaging conversation, not short on opinions and thoughts and deep expertise as well. So really, really enjoyed the conversation. Thank you very much.
Thanks so much.